Hello, everyone. Hey, thank you for coming. I honestly didn't expect anyone to show up, so this is going to be difficult. But I appreciate you coming. Just to start things out real quick. How many of you have actually have like used metal? Raise your hands. That's awesome. That's awesome. Cool. All right. Uh, Swift. Okay, that's what I was hoping. That's great. I should talk that. All right. Um, well, this talk basically revolves around the two, and hopefully by the end of it, uh, you'll and there'll be more hands raised next year when it comes to using metal. Um, so a little bit about me. Hopefully this is yeah. I'm Basil. That is my spirit animal. That is a character from a comic book who works as an office person and is exhausted constantly, and so that's kind of what I'm known for. Um, I'm on Twitter, and I am trying to write a book, and yeah, no one told me that was gonna be hard or whatever. So, uh, so I'm gonna start out with you know what is metal. Um, cool. This is good. This is already going well. Uh, I put Slayer up because I love Slayer. Because that's well, I don't love Slayer, but they're like the most metal band of all time. Um, but metal, as we know, is a framework that was given to us by Apple in order to reduce the overhead, right? When it came to implementing graphics, and people recognize this less, but lower the overhead of uh, power necessary for like computational sort of activity. Um, um, why did and I'm focusing on metal um, because to be honest with you, I don't really care about the graphics. So if you're here for like graphics, I'm so sorry. Like this is not what it's going to be about, because I think that channel has been explored pretty thoroughly by people much smarter than me. Simon Gladwell has done some really great stuff on image. Uh, Gladman, it's fine. He'll never know. Um, so he's done some really great stuff on image processing. So I have no interest in triangles or teapots or what have you. So just a heads up. So this is a quote I really love. It's by Seymour Clay, supercomputer genius. If you were plowing a field, which would you rather use? Right, 2 strong oxen or 1,024 chickens? Anybody? Heck yeah! I love chickens. Yeah. Right, and there's a point to that, right? He's this is kind of, I mean, this is a reference to parallelism, obviously, right? Um, Back in the day, which is I guess was Wednesday, uh, um, parallelism wasn't, it was a niche thing, right? If you had a supercomputer, you could do that, right? Um, and now we all have the power to, to create programs that take advantage of parallelism when it comes to the GPU. So I don't know what my next slide is because it's supposed to give you a preview, but it was decided not to, so this will be fun. So yeah, why is this important? Why is this all important, right? Well, we're increasingly living in a world where our only means of increasing computational power is via the GPU, right? The laws of physics now limit us from actually maximizing the CPU any further, right? And so now we've kind of shifted our focus into putting as many cores, right, and focusing just on gates, right, into our GPUs. And I'm sure that'll, I'm sure we'll burn that out eventually. But until then, and it's important because we live in a world where we're not just dealing with the data, 10,000 pieces of data, right? We're dealing with millions. I did an interview with LinkedIn a couple weeks ago, and the senior engineer was like, "How do you feel about dealing with like billions of data points every day?" And I was like, "Do you mean like millions?" And he said, "No, I mean like billions." So that's the world we live in. We are going to have to become accustomed to dealing with and solving problems that involve almost incomprehensible amounts of data. So what's parallel programming, right? That's probably the first question you might ask. My answer to you would be that first, because it is, right? Parallel programming. I've been working on this for a while, and I read like a couple of different textbooks, some studies from the ACM, and everybody has their own kind of like. I mean, the what's done is the same, but like the sort of philosophical view on how to maximize it is different, and the actual act of conducting it is pretty hard, right? Just a second. So, we can stop. So parallelism, right? Ultimately, if we go back to the chickens, right, is what allows us to solve these large problems by breaking them into smaller pieces, right? We have hundreds of processors, so we can actually do that. The modern GPU, I think, has about 65K threads, right? So just tens of thousands of concurrent threads. So via parallelism, the number of algorithms and the techniques where we want to implement and where we want things to specifically communicate with one another. Like there's more flexibility around that, and we also have this idea of the general performance GPU, right? GPU. And some of you might be thinking, "Hey, Basil, I know you're talking about using parallelism for computational problems, but like, haven't you heard of this cool thing called the math library, Accelerate?" And I would say, yeah, except the problem with Accelerate is actually not precise. And I was gonna post this. There's like a 2-page rant from like an old Apple thread from an internal employee about how furious he is with how the fact that floats are just like not even close, in his opinion. So metal brings you closer to accuracy, and it was and honestly, the math libraries never meant to be precise. They were supposed to wobble. So let's move on a little bit. What is data parallel computing? Just a second. So yeah, so via data parallelism, we can do a lot of the things that I was mentioning earlier, right? With parallelism, we're talking more about sort of actions that can be executed either simultaneously or concurrently, and are void of any particular type, right? Like it could be anything. It could be in some sort of asynchronous call, right? Or I mean, I guess. But with data parallel computing, right? What you're trying to do is, from a high level, take really large data sets, perform calculations on them, and pray to God that SIMD doesn't screw you over, right? In the case of metal, right, there's already a system in place, thanks to the good people at Apple, which takes care of that for you. You don't have to worry about what's going down the pipeline. Locks, and your whatever nightmare you have, you still have. It's not there, right? You might still have to use semaphores, but that's just the nature of the beast. I'm so sorry. My notes were on the thing with the proliferation. Okay. Background. Yeah. So yeah. Thanks to the proliferation of GPU research and the subsequent improvement in GPU capacity, we can tap into the GPU. If us GPU alchemists suddenly have a bunch of resources for designing and maintaining, testing, and creating new types of performance systems, right? And we can do this because of parallelism. And to get to a more granular level, right? We're able to do this because of threads. If you don't know what a thread is, threads range from the GPU, and we're able to handle problems involving multiple calculations or instructions because we have access to them. Cripes. So let's go to the next thing. We can kind of trace the proliferation of GPU advancement, I think, to that of video game nerds. I just wanted to give a quick history about it. I mean, most people wonder, like, well, why don't we continue to focus on the CPU? Again, laws of physics prevent us from doing that. Also, there have been incredibly strong market forces from the video game community to make things cooler, brighter, faster, stronger, whatever. And so that's what's given us the opportunity to actually take advantage of GPUs in general. So thanks, nerds. Now we're getting to the part where I think things get interesting. So the reason why I really wanted to do this talk wasn't to tell chicken jokes or explain parallelism to people or what a thread is or how that operates. It's to show you what I see in the potential of Swift and Metal. I see Swift, and I'm breathing way too hard into this. I did a number of tests with Swift whilst leveraging Metal, and whilst sort of doing these like operations, whether it be simple stuff like, I don't know, some sort of sad linear regression or what have you, depending on the context. I wanted to see what the speed and of the computations were like. Now, why would I care about the speed? Right? Surely speed is not the only indication of performance or the potential of something. I think NumPy and Python proves that, right? The reason why I wanted to see that was because of machine learning, which is something that I'm greatly interested in. In machine learning, not every sector, but there are sectors like neural networks, which are the new, and deep learning in general, which is like the sexy thing now, right? Speed is incredibly important, right? If you can knock off even 0.1 of a second, people will love you. And so what I wanted to see was, well, could one leverage Swift and Metal to deal with these large data sets? Because that's essentially what neural networks and a lot of these deep learning models deal with, right? What you have to do is you set it up, and then you have to leave, and you need to take time to learn. You needed to give it time to parse all that data and learn all this crap, right? Crap is a technical term, and like that takes time, right? And I wanted to see if there might be a difference between with Swift and Metal, and there is a difference. Although the difference was, like a lot of experiments, counter to what I had expected. What I got out of this was, when it comes to trivial amounts of data, Swift and Metal sucks. Like, just use Accelerate. As much as I hate to admit that, and my friend Marius is probably somewhere laughing right now, but it's not good for it. But if you notice in the charts, as the data points increase, would you look at that? Interesting. Things start to speed up, and it's not just in the case of comparisons within the language. I also took a bunch of other libraries and made some comparisons as well. Unfortunately, my site is down, but I will post that to post-haste probably after the talk. What I actually ended up doing was try to replicate the NumPy library in Swift. I did that with a graduate student out in Utah, and what we essentially discovered is that same thing, right? Like, when it comes to low data points, do not use Swift plus Metal, right? Even NumPy laughs at it. Even R laughs at it. But as the data points increase, suddenly you see a performance that is on par with even languages like Julia, which scared me because I thought, I mean, that's insane. Even Scala. So that's the potential I see. Why do I think this is important? Because machine learning is increasingly eating up everything. Google has promised us to train all their employees in the machine learning by 2025. And I watch them very closely because they're evil. And so I know that whatever they do, like, we're going to have to do eventually, right? And so to me, this is an opportunity to present a means to an incredibly complex topic via a somewhat accessible means, right? Metal's not pretty. I admit that. I have metal code that I was going to show you guys, but then I was like, they don't deserve that, right? Like, it's still not, a piece of cake, but it's getting there. Every year, I see more and more improvements during WWDC, and I think it's important. I'm still punk rock, no matter how old I get. I think it's really important for there to be a democratization of the ability to do complex tasks like that, right? If the only people who have access to supercomputers are Stanford scientists and people who misidentify African Americans for gorillas via the image recognition programs, maybe we should try to diversify and give the masses a chance at it, right? That's really it. I see a really strong. I see an open opportunity. One of my projects, my entire project now is dedicated towards making Metal and Swift so easy to understand that a 5-year-old could pick it up and have no problem. And I have probably the capacity of a 5-year-old. So it's going to happen. It's going to get done. And I'm joking, but I'm also not. Gosh, was that it? That's so sad. Wait, no, that's 30 minutes. Is it 30 minutes? Eli, help me out. How long do I have?
Well, we just depends with so you have until.
I mean, I can talk. I don't know.
Questions about that?
Sure. I mean, if you want to, yeah. I guess if you guys want to ask questions, sure. I don't know why I said that in that manner. I'm so sorry. Right? Please ask questions. I saw you first. I'm sorry.
We actually see the code?
Yeah. No. So what this is actually the sexy code is. Where can I post things, because I didn't even know that they changed the room on me until 5 minutes ago. So maybe what I'll do is I'll post the GitHub repo on the attendees thing. This was just supposed to be see. Well, that doesn't help, right? Hang on. Okay, well, I will post it. So basically, no, and I'm guessing the reason why you want to see it is to make sure, the benchmarks and all that stuff is good, and I would appreciate that actually, because I've made mistakes before. But I think I'm pretty close on this one. But what was your name?
I'm Eric, and I haven't worked with Metal
Oh, that's fine. Oh, sorry, I didn't mean to be like accusatory. I just meant like that's usually why people like. All right, buddy. Like, let's look at your numbers. Um,
Why is you alluded to it a few times and you have data for it, but you've never explained why it's slow with why swiftness metal is slow with low data sets.
that is an excellent question. Um, I don't remember why, and I don't know why, but I would really like to get back to you on that. I just remember being upset. So let me write that down.
Let me rephrase that. Why is NumPy slow with low data sets as well? Because you said the same thing.
Oh no, Python's a slow language in general. That's all. Yeah. What was your name? Arthur. I'm going to email you with an answer. So please see me afterwards.
So in my office there are some people doing some C++ desktop GPU multi-thread stuff. Do you think I should be looking at guiding them to using a Mac with a desktop GPU?
Well, that's my goal eventually, right? Like my goal is to, but it depends on the research. So here's the thing about machine learning. People act like it's like new. It's not, right? It's been around for like 30, 40, I think maybe even 50 years. It's just, it hasn't been cool. Right now, it's cool and sexy, and so everybody's doing research on it. But if you look at like charts, you'll notice like dip in the 90s, nobody cares. And then now everybody wants to do deep learning, right? My goal is to get there is to get to the point where it's like, okay, maybe I have to spend 20 grand, but I don't have to spend 200K for NVIDIA's bull, right? But yeah, like I would, depending on the context of their research, like obviously if they're dealing with an entire nation's census data, probably not best to handle that on the Mac, but like, unless they're clever and they know how to combine the powers of multiple Macs, in which case, yes, do that. There's a Chinese researcher, I'll post that link too, actually, who did something like that. What was your name? Adam. Okay. You should see me afterwards too, Adam.
Have you compared performance between anything else like Cafe and TensorFlow?
Well, since those are more frameworks, no, I was just comparing languages. Well, that's a fair question. No, I didn't. I was just like, okay, well, let's look at this language, Python. All right, R. Okay, MATLAB. Blah blah blah. TensorFlow, I didn't think of as a potential, but you can implement Swift plus Metal with TensorFlow via CNN. In fact, there's an example code for just that on the Apple website, and it's pretty awesome. And it's the simplest explanation I've seen of a CNN ever.
One more quick question, if you don't mind.
Yeah.
Have you tried it all the combo nets that Apple released in, I guess was iOS 10?
The accelerate stuff.
No, I thought they had some MPS performance shaders or whatever.
Yeah, you're talking about Blast, or no, not Blast. Are you talking? So okay, are you talking about accelerate, or what are we talking about?
No, I think it's part of the middle framework.
It is part of the middle framework. That's what I was just trying to make sure that I understood you. So have I played with that? No. Because I wanted to not change too much. In fact, this code's already outdated. So I haven't tried playing with the new frameworks because when I did try to do that, it broke everything. So.
My question is, when Apple first released Apple, they said they're removing all the stack intermediate frameworks and giving direct access to the CPU
GPU so developers can have access to that. What do you think? Have they been successful, or what are your opinions on? Have they been successful? Is it easy?
So,
Can Swift developers get in and write code?
so I rolled my eyes not because of your question, but because what you're asking, it was like you're talking about when they were like, oh my gosh, it's 10 times the trial calls, right? That's just market talk, right? That is the maximum it has the potential to reach, right? Like 5 megabits or whatever, and the internet companies con us into, right? But it never really reaches that all the time, or maybe ever. So, I'm not sure what you're referring to though in terms of like, has it been successful?
As opposed to other approaches to do, let's say, machine learning?
Oh, I see. Yeah. No one's. I'm venturing into uncharted territory. Warren Moore is a friend of mine, and he's really into metal. And I remember when I asked him, "What computational examples do you think we could come up with metal?" And he was like, "Well, we could do this physics, thing and see." And I was like, "No, you idiot! Look, it's right in front of us. We could try this." I didn't call him an idiot because I'm scared of him. So, like respect, not like. So you can tell him that. I don't care. He knows. But yeah, for whatever reason, when people think of metal, they don't think about the potential, the enormous potential for just raw computational horsepower. So.
So one of the challenges I think that I've had with NumPy and to a lesser extent is like RAM usage, like the way Python represents data structures is very expensive. How does Swift measure up?
Yeah, cache rules everything around me. Yeah. So it has like it depends on what platform you're using, right? Like if you're on the Mac OS, it's a discrete system, right? And on iOS, what I know they try to do is leverage the CPU and the GPU, but I'm not quite sure what they do with Mac OS in terms of how to handle it. Because you can't like I can't go to the granular level, right, and mess with stuff so that I can get the sort of maximum and maximal speed and performance, right? Because Apple still has the gate in front of me. So the only thing I found to like deal with that is better algorithms and better like sort of reframing the problem, right? So the answer to your question is how does it deal with that? Depends, and I think it depends on how persistent and clever you are. So. Very exciting stuff, I know, I guess. GPUs are cool. No one? David? Okay, yeah.
So, like previously, if you're going to do like high performance computing and stuff, you have a cluster and you would distribute the computations across the compute cluster. Like now, you could do something similar with Amazon and using their GPUs and things of that nature, right? So, like does Metal have like an MPP type process that you could distribute your computations across multiple machines?
I don't know. That's a great question. What's your name?
Like,
I need you after this. I'm trying to write a book. There are things I haven't thought about. People are always asking me questions. I'm like, that's really great. I don't know. but that's actually an excellent question because then that makes that completely possible, right? So. I'm only like physically like clumsy and incompetent, but like I can answer your questions.
Do you see this as potentially opening the door for the scientific community?
No. Because here's why. Sorry, I don't mean to be cheeky. The thing about machine learning I've discovered is that there's no one, like, it's not like Highlander, right? There's no one language to rule them all, right? Depending on the problem you're dealing with, a certain framework, a certain language is going to be more appropriate. I picked this because that's where a large amount of the research is going to, right? Deep learning, neural networks, Silicon Valley, goes crazy over that, right? And since the advantage here is performance speed, well, I think it's an appropriate tool. Is it an appropriate tool for every case? Probably not.
So it's just another tool.
Just another tool, but a tool better than the rest in that sector. So
I'd venture to disagree with you. Not because I'm an expert, not Swift.
I'm not an expert on anything, so that's fine.
You're the rest of an expert.
Cool.
Alright. Only because I did science back in the day before I did do iOS stuff.
Yeah.
And we were using Fortran and C, and this was like 8-10 years ago.
Yeah.
So anything is an upgrade from that. Even if for parallel processing stuff, I mean, all the parallel processing I've ever done was written in C. We just shut off to get the results. So I would venture to guess that using Swift and any other framework would be better than what currently exists for a good chunk of what's funded by the Department of Energy for a lot of scientific research.
That's true, and that might be true. Talk to a Harvard professor, forget his name, and ask him that, and see what he has to say, because someone else said the same thing to him, and he had an answer.
It depends what his age is, because after a certain point, people
He's
will
30.
change. He will change.
That's true. You're right. I asked, but the reason why I say that, again, not to be cheeky, I asked him the same thing, right? And he was like, so.
You were awesome.
Yeah.
What's the greatest challenge you solve with metal?
Figuring out how to use metal. That was step one. I was like, oh, I get it now. You can leverage the buffers. Why throw them all in at the same time? You can just have one waiting in the wings, right? No, but in all honesty, the thing I'm most proud of is this comparison, these comparisons that I found. Nobody thinks about it, and it really annoys me because it's there's so much potential there. Apple doesn't. I mean, Apple like this year was like, we're gonna do neural networks now, like, and it makes me feel like I might have said something to Warren, and he had something to do with it. So I'm suspicious of him now. He's on their GPU team, so. But instead of thinking about video games, let's see what's happening on the other side. So video games are still cool, guys. I love them. So
What are some of the favorite stores in the App Store that use metal?
stores.
Apps.
Oh, apps. Memkite. Memkite is a project by two probably Swedish PhDs. They basically have created a framework for. They basically created a store for deep neural network learning, which I thought was really interesting, right? Because training neural networks is the worst thing in the world. It feels like sometimes. But if you have a store that, they're in beta, by the way. They're not on the App Store. So just Google them, kite. Yeah. So. Cool. I don't have to think about this anymore.